So in the last video, I asked you to define what you think a square is, anything you could remember about squares. And the technical definition is that it's a quadrilateral, a four-sided shape with 4 right angles and 4 congruent sides. So all of the sides are equal measurements and all of the angles are equal and they're all 90 degrees. And it has 4 sides. Now, this sounds familiar. 4 right angles means it's a rectangle. 4 congruent sides means it's a rhombus. So technically, it has all of the properties of parallelograms, rectangles, and rhombuses. So every single property that we've discussed about all of those shapes apply to squares. Okay, now our example for this is a graphing example. So if you don't have any graph paper, make sure you get some, because you can't do this without actually graphing these points. And it has to be done on graph paper, even your homework. So make sure you take home extra paper if you need to. Okay, in example 3, it says, show that the diagonals of square ABCD are congruent perpendicular bisectors of each other. They gave us point A is -1, 0, B is -3, 5, C is 2, 7, and D is 4, 2. They want us to show that they are congruent. So we're going to start with that word. Congruent means that they are the same length. So when you graph it, you can see that this blue line, BD, is one of the diagonals, and AC is the other one. So you need to use the distance formula. Subtract, square, add, and square root. So pause the video, try and use the distance formula to find the length of AC and BD. You should get the same measurement for both of them because it said congruent. So I put in my measurements. AC, the x values are -1, 2, so I did 2 minus -1, which is 3. And then I squared it, I got 9. Okay, and then for my y values, I had 0 and 7. So I did 7 minus 0 is 7. 7 squared is 49. And I added those together to get 58, and it's the square root of 58. For BD, I used the x values first, so I did 4 minus -3 to get 7. 7 squared is 49. And then I did 2 minus 5 to get -3. -3 squared is 9. If I add those together, I get the 58, so it's the square root of 58. And these are the same number, which means that they are congruent. Next, the next word says perpendicular. Now, with graphed lines, to show that they're perpendicular, I use the slopes. So I'm going to count the slopes and show that those slopes are opposite reciprocals. So again, pause the video, try and do that, and then press play to see if you got the right answer. Okay, for AC, it rises 7 and runs 3. And for BD, it goes down by 3, and then it runs 7. So I have 7/3 and -3/7. These have opposite signs, and they are reciprocal, meaning they flipped the fraction. So yes, these two lines are perpendicular. Now, the final word they used is bisectors. So the way we show that it's a bisector is we find the midpoint of AC and the midpoint of BD. And if it's the same exact point for both of them, then yes, it's a bisector. Yes, it cuts both of those segments in half. Okay, so pause the video and remember, midpoint, you average the x's and average the y's. Add and divide by 2 for the x's, add and divide by 2 for the y's. And you do it for both BD and AC. Okay, so I'm going to do -1 plus 2 divided by 2 to get 1/2, and 0 plus 7 divided by 2 to get 7/2. Now for the other point, -3 plus 4 is 1, divided by 2 is 1/2, and then 5 plus 2 is 7, divided by 2 is 7/2. These are the same point, so they bisect each other. Now you're going to try it on this next check it out question. You're going to do all of these steps, same way I just did. So here you go. It says the vertices of square STVW are S, T, V, and W Show that the diagonals are congruent perpendicular bisectors of each other. So it's the same steps we just did. So pause the video, do all those steps, and then press play to check your answer. So if you used your distance formula properly, you found out that SV and TW are both the square root of 122 units long, so they are congruent. If you found your slopes properly, you'd find that SV is 1 over 11 and TW is negative 11. So these are opposites because they have different signs, and they are reciprocals, making them perpendicular. So SV and TW are perpendicular. Now finally, if you found your midpoints for both lines, you got 1/2 and negative 7/2 for both of them, meaning that they are bisectors. So you just had to do the work for all three of these, and you get your answer. Now we have one last example to talk about. Okay, in example 4, you're given a proof. It says EFGH is a rectangle, and J is the midpoint of EH. They want you to prove that triangle FJG is isosceles. So what you're going to do is you're going to pause this video, talk to everyone else in class, and see if you can figure out how to prove this. Try and find some steps. And when everybody in class is ready, you're going to press play to see what the actual steps are. And no cheating from a textbook, okay? Okay, so what I figured out is that to show that this triangle is isosceles, I have to show that this side, FJ, equals JG. And in order to do that, I'd have to show that this triangle here is congruent to this triangle here. So I know because it's a rectangle that angle E, and angle H are both right angles. And that's the definition of a rectangle. And because they're both right angles, I know that they're congruent to each other because of the right angle congruence theorem. So that's the angles that are equal to each other. Now I also know that this is a parallelogram because all rectangles are parallelograms. And these are the shorthand symbols for saying that. If it's a rectangle, then it's a parallelogram. And if it's a parallelogram, then I know that EF is congruent to GH because they're opposite sides. And in a parallelogram, opposite sides are congruent. Now, finally, in my given statement, they said the word midpoint. J is the midpoint of EH. So because it's a midpoint, I know that EJ is congruent to JH. And that's the definition of a midpoint. So these two triangles are congruent using side, angle, side. And I can use CPCTC to say that FJ is congruent to GJ. And because I know that two sides of that triangle are congruent, I know that the triangle is isosceles using the definition of isosceles. Okay, so that's it for this lesson. Please let me know if you have any questions about anything, and hopefully I'll be able to see you soon.